So what we're going to be looking at today is simplifying expressions that involve powers and negative exponents. And this should actually also be reviewed for us from Algebra 1. We have our different power rules. That's what we're going to be writing down, and then we're just doing a lot of examples today. So our first rule is the multiplying powers rule. And before we do that, let me label some things for you guys. If I give you, and all of my rules are going to be just written in general terms for right now. If I give you something that looks like this, a to the m, we call that a, this is the base. So it's either going to be an exponent or it can also be a number. And then the m or the n or whatever is the exponent, and that will always be a number. In general terms, we always write them using a letter because we don't want to give you a specific number so that you fixate on a specific number, which is why it's always written in general terms. But whenever I talk about base, that's what I'm talking about is the big number. The exponent's the little one. Whenever I'm talking about the base, that's this big guy. The exponent is the little guy. So when we're multiplying powers, our bases have to be the same. So that exponent, or if they happen to be a number, they better be the same, okay? The exponents do not have to be the same. So when I'm multiplying two numbers with the same base, I keep that base, and then I add the two exponents together, okay? So the trick here for multiplying the powers is that you are adding the exponents. Okay. When we are dividing powers, the bases still have to be the same, so we keep that same base, but then I subtract my exponents. So when I'm multiplying, I add the exponents. When I'm dividing, I subtract the exponents. I always keep the same base though, so that base still stays the same. The exponents get subtracted. We also have what is called a power of powers. That means that I am taking something with an exponent and then raising that to a power. So there'll always be parentheses around it. What happens then is I take the base, keep it the same, and I multiply the exponent. So if there's ever parentheses with a power attached, that means that I'm going to be multiplying the exponents together. Along with that, sometimes we have two different bases inside the parentheses. So in this case, A and B are both two different bases, and those are being raised to an exponent. I call that distributing the exponents, and I put distribute in quotes because technically it's not distributing. We have to give that exponent to each base inside the parentheses, so it's going to turn it into A to the m times B to the m. Or if we're dividing, that m gets distributed both on top and bottom, and it becomes a to the m over b to the m. So we're giving the exponent to each base, even if it's a number, but technically it's not distributive property because we're not multiplying this number times the base. We're raising the base to that exponent, and there's a big difference. When we do an example, I'll show you. But there is a difference between multiplying this exponent by the base and raising it to the power. We're multiplying the powers, not the bases. Okay, a couple other things before we get into examples. Sometimes we will see a negative exponent. Whenever you see something with a negative exponent attached to it, we always have to move it to the opposite place in the fraction, or take the reciprocal of that. Now that doesn't mean always take the reciprocal of the whole thing, just what is negative. So for example, this a to the negative m, that's the same as a to the negative m over 1. So we take that guy and he has to move downstairs, and when they move, then the exponent becomes positive. It works the other way too. If I have 1 over a to the negative m, that has to move upstairs, and then it can become a to the positive m. So the negative is kind of like a red flag for us saying this is in the wrong spot. So we have to move it, and then it can become positive. Okay, so it does become positive after we move it. The negative is just kind of like a warning that it's in the wrong spot. And then last little bit before we get to the first example, anytime you raise anything to the 0 power, it's always equal to 1. Okay? So anytime anything is raised to the 0, it always is equal to 1 no matter what. On the same token, if I ever have something that looks like just an x by itself, what would the exponent be there? If there's no exponent, what would it be? It's a 1. Okay, we will use that. Alright, so anything to the 0 is always equal to 1. If you ever get something like x by itself, it actually has an exponent of 1. Okay, so just make sure you keep that in the back of your mind as well. Okay, so let's look at a couple examples. I put the instructions here just so that you know what simplify actually means. So for example 1, your instructions are to simplify, and simplifying means leave no negative exponents in the answer. So you should have 0 negative exponents. You need to make everything positive. We also want to have only 1 of each base. So sometimes we will have, after we simplify a little bit, we'll have 2 of each base. Then it's still not simplified all the way. You should only have 1 x in there with an exponent, 1 y with an exponent. You should never have more than 1 of each base. Okay? So example 1. So example 1 is multiplying. So we multiply our coefficients. Our coefficients we can just multiply by each other. So what's 2 times negative 4? Negative 8. And then you can only multiply the same bases. So let's put that note here. You can only multiply the same bases. Okay, so what does that mean? That means I can only multiply a times a. And what I'm going to do first is I'm going to show each step just so that we can get used to doing this. So I'm going to combine my a's with 1 base. And if I'm multiplying those powers, what happens to the exponents? What do your notes say? They add them. So this a has an exponent of 1, and we're going to add it to the other exponent of 3. Same thing with the b's. We have b to the 2nd power plus the other b was to the 3rd power. And then c is kind of hang out all by itself, so we just put c on at the end. So let's actually simplify this all the way. That's negative 8. A to the 3 plus 1 is 4. B to the 5th, C. We have no negative exponents in here. A only shows up once, B only shows up once, and C only shows up once. So we are simplified. Example 2. X to the 11th over x to the 5th. What do your notes say we do when we are dividing? Subtraction. So we keep the base, which is x. So this is going to be x to the 11 minus 5, which is x to the 6th. No negative exponents there. Only one x. So that's your answer. So for example 3, we have y to the 20th over y to the 30th. This is similar to the previous example, so what am I going to do with the exponents? Subtract them. So this is the same as y to the 20 minus 30, which is y to the negative 10. Am I simplified all the way?
Yeah.
No, there's a negative exponent in there. What happens when I have a negative exponent? I have to take the reciprocal, so that's going to become a fraction. So this is going to be 1 on top over y to the 10th, and that's your answer. So after we move the y down below the fraction, that 10 becomes positive. There is a shortcut here. So what do you guys notice? Look at our original problem. I have y to the 20th and y to the 30th. What number is bigger? 20 or 30? And where is that 30? Is that on top or on bottom? Bottom. Where did our answer end up? On top or on bottom? Bottom. So our answer is always going to end up with on whichever top or bottom has the biggest exponent. Okay, so you can subtract and just put your answer where the bigger exponent is. So let's put that note there. When dividing towers, the answer ends up where the bigger exponent is. So either top or bottom. Example number 4. We have 1/3 to the -5th times 2/3 to the 4th. My suggestion, whenever you see something that looks like this, simplify it as much as possible first and then worry about the negative exponents. So if you guys go back and look in your notes, what did it say we're supposed to do when I have like a fraction to an exponent? Distribute the exponent. So 1 goes to the top and then it also goes to the bottom, and we're going to do this with both of them. So rewriting this is going to be 1 to the -5th over 3 to the -5th times 2 to the 4th over 3 to the 4th. Okay, so now let's worry about our negative exponents. So where do you guys see negatives? The 1 and the 3. So basically this 1 goes down and the 3 comes up. So this is going to become 3 to the 5th over 1 to the 5th times 2 to the 4th over 3 to the 4th. Am I simplified though? What do you guys think? How many sets of 2 do I have? 2 only shows up once. How many times does 3 show up? Twice. So we can simplify a little bit more. So this is going to be the same as 3 over 5 divided by 3 over 4. So what do I do with the exponents there? Subtract. Where's my answer going to end up, on top or on bottom? Which one's bigger, 5 or 4? 5. So my answer is going to end up on top. All those 3's are going to go away, and what's left on top? 5 minus 4 gives me 1. So this is 3 times 2 to the 4th over 1 to the 5th. And then just a couple of nitpicky things. When you are writing your variables out as your answer, we like to put the variables in alphabetical order, right? So that we always do X, Y, Z, or A, B, C. When we have numbers, we like to put the numbers from smallest to biggest. So this is actually 2 to the 4th times 3 over 1 to the 5th. And sometimes it will be acceptable to leave your answer even with numbers as your bases with the exponents, especially if the exponents are large. But these are really small, so let's actually multiply it out. What's 2 to the 4th? 16 times 3 over, what's 1 to the 5th, guys? 1. So my answer is actually going to be what? 48. So you can multiply it all the way through. If the numbers are small like this, I expect you to. If you get something like 3 to the 205th, obviously I don't expect you to do that. You can just leave your answer. Okay? Even like 3 to the 15th, I don't expect you to do that. Something like 2 to the 4th, though, you can do that. Okay, so if it's something small, use your discretion. Go ahead and multiply it all the way out. Okay. Example 5 is going to be another example of that. So we have 5 to the 2nd times 5 to the 0 times 5 to the -4. So looking at this problem, are all of my bases the same? 5, 5, and 5, are those all the same? Yeah, so we can combine these. What will I do with the exponents? Will I add or multiply or subtract? Add them. So this is going to be 5 to the second plus 0 minus 4, which gives me 5 to the negative 2. And this is not simplified because we have a negative exponent. So that 5 to the negative 2 has to go down below the fraction. So what's going to be left on top? If I take that 5 to the negative 2 and move it down, a 1. Below the fraction is going to be 5 squared. And we should all be able to do 5 squared. So that's going to be 1 over 25. So that's just what I mean. If it's something totally easy like 5 squared, you can do it. If it's something crazy like 5 to the 10th, don't do it. Okay, it'll take way too long. Okay, let's try a little bit more challenging problem. 3x to the 5th, y over negative 6x to the 6th, y to the 3rd. Okay, so once again, I want to actually do as much as we can before we worry about that negative 2. Everything in here can be simplified a little bit, so why don't we simplify it first? So inside the parentheses, where do you guys see stuff that can be simplified? The x's and y's. Okay, so we have x to the 5th over x to the 6th. Where would my answer of x's end up? On top or on bottom? On bottom, because 6 is bigger. So all those 5's are going to go away, and that 6 is going to turn into a 1. What about the y's? Will my answer end up on top or on bottom? On bottom, because 3 is bigger. So that 1 y is going to go away, and this y is going to turn into a 2. Good. What about the 3 and the negative 6? Can that reduce? Yeah, 3 goes into negative 6 how many times? Negative 2. Okay, so let's rewrite all of that first. What's on top? What's left? Just a 1 over negative 2 x y squared. All of that to the negative 2nd power. So simplify everything first, and then we'll worry about the negatives. So now, what happens when I have all of this stuff to a power? We take that power and we distribute it to everything. So that 1 is not being multiplied by negative 2. It's being raised to negative 2. Okay, there's a big difference. Alright, so that negative 2 also gets put to that negative 2, to the x, and to the y. Okay. So what's that going to give me? Once again, this is not 1 times negative 2. This is still a power. It will always be a power. So this is always a power. Okay, so this is going to be 1 to the negative 2nd power over, same thing, negative 2 to the negative 2nd power, x to the negative 2nd power, y to the negative 4th power. Now obviously we're not done because we have all these negative exponents. The entire top has to move to the bottom, and the entire bottom has to move to the top because every single one of them is negative. So that puts me on top, negative 2 squared, x squared, y to the 4th, all over 1 squared. Negative 2 squared. Let's look at that. Is this the same as that? Look at these two things. Are these two the same? No. What's the difference between this one? What's that exponent attached to? Just the 2 or the whole thing? Just the 2. So this is the same as saying negative 2 times 2, which is really negative 4. What's this saying? That's negative 2 times negative 2, which is positive 4. So if there's not a parentheses around the negative 2, only the 2 is being squared. So what is that actually reduced to? Negative 4. X squared, y squared. What's 1 squared? Do we have to write it then? No. So this is our answer. Okay. So example 7, we have 4t on the outside, s to the negative 1, t to the negative 3. All of that to the negative second power. Now I don't want you to worry about any of these negative right now, because look what's going to happen. When we follow order of operations, we do parentheses first. Inside, there's nothing here else we can do, right? Because s's and t's can't be combined. So then we go to exponents, which means I have to do this guy. So I'm going to distribute that negative 2 exponent to the s and to the t. So 4t comes straight down, and that's going to be s. What's negative 1 times negative 2? Positive 2. So it made it positive for us. T to the positive 6. So always worry about the negative exponents last, because sometimes they get turned into positives, which is nice. Okay? Now, question for you though. Am I simplified all the way? No, I have only one set of s's, but t shows up twice. This is t to the what power right here? T to the first. So if I have 4t to the first times s squared times t to the 6th, what am I going to do with those exponents of t? Multiply or add them? Add them. So let's put everything in order. 4 s squared t to the 7th. Example 8. X to the negative 3rd, y squared, over y squared times 1 over xy. This is a case in which I would start worrying about the negatives first, only because it's going to be harder for us to combine these two things because of that negative exponent. So let's take that negative, and that negative has to move downstairs. Does the y squared have to go anywhere? No, it's positive, so it gets to stay. Okay, only the ones with negative exponents have to move. So this becomes 1 over x to the 3rd y squared times 1 over xy. Now we just get to multiply straight across. So 1 times 1 gives me 1. X to the 3rd times x, what's that going to give me? X to the 4th. Y squared times y is y to the 3rd. And that's your answer. I know. Okay, example 9. You're going to want to see this anyway. Okay, so example 9, we have this whole big thing. Now the reason why, if you guys look at your previous example, example 6, hold on. Alright, look at example 9 and then go back and look at example 6. What's the difference between the way 9 looks and the way 6 looks? It has to do with the parentheses. What do you guys notice? In example 6, there's one big set of parentheses, and so we were able to simplify inside. In example 9, there's 2 sets of parentheses, and both are being raised to 2 different powers. So we can't simplify the tops and bottoms before we distribute. So we have to go straight to distributing those exponents. To the 3, to the c, and to the f. So you have to do it to the exponents as well as the numbers. So all I want you all to do is rewrite this with all of the exponents. Okay, so what do we have? 6 to the negative first. 4 times negative 1 gives me negative 4. And f to the negative 3 times negative 1 gives me positive 3. All of that over 3 squared, c to the negative 6, f to the 6. Is that what you guys got? Okay. Next step, and I know we're getting close. Take everything with a negative exponent and move it either up or down. So that 6 to the negative 1, c to the negative 4, and c to the negative 6 get moved. So it becomes c to the 6th, f to the 3rd, over 3 squared times 6 to the 1st, c to the 4th, f to the 6th. And then let's reduce really quickly. The c's can reduce, and there's more on top than on bottom, so that becomes c squared. F's reduce, and there's more on bottom, so that becomes f to the 3rd. 3 squared is actually 9, so 9 times 6 is going to give me 54, so that is c squared over 54 f to the 3rd.